All right, what do we have here? We have 11.5, the margin of error and the confidence intervals. A sample of scores from a recent English 4 test was taken. The sample mean is 55 and the sample standard deviation is 9.7. S of x is sample standard deviation. If the margin of error was found to be plus or minus 3.6 for a 95% confidence interval, how many kids were in the sample? So I noticed that it speaks about the 95% confidence interval. And for a 95% confidence interval, the margin of error is going to be 2 sigma sitting pretty over the square root of n. All right. Now, I want to know how many kids are in the sample. Well, the margin of error is 3.6, and it must equal 2 standard deviations, so twice 9.7, sitting pretty over the square root of n. And then I'm going to do some math, kids. I'm going to multiply both sides by root n. Multiply the right by root n, which means I multiply the left by root n. So root n times 3.6 is going to be twice 9.7, which is what, 19.4. Next move, divide out the 3.6. And this gives me the root of n is 19.4 over 3.6, whatever that is. And the opposite of square rooting is squaring. So that's what I'm going to go push buttons on in my little fancy TI-84 over here. I'm going to take 19.4. I'm going to divide it by 3.6. I don't like to do a whole lot of stuff at once. And then I'm just going to square that result. And I'm going to round accordingly. There's about 29 kids. N is about 29. All right. Let's jump on to 3. A 95% confidence interval for the United States mean income is given as 62,500 to 67,000. The sample size is 1,000 citizens. Is the data qualitative or quantitative? It is quantitative. It is numerical. All right. It's not a quality. Determine the sample estimate for the mean income. So I want to know what the average was. The mean means average, all right? And the average of two things happens when you add them together and divide them by 2. It's literally the number in the middle. So you add them together. I don't know why I put a 200 there, and you divide by 2. As tired as I am, I don't know why I'm going to a calculator like I've become y'all. It should be 64,750, but I'm pretty tired too. I know that's wordy and that's going to bother you all, but it's 64,750. Reading comprehension, right? You didn't understand what the question was asking. Determine the margin of error. The margin of error is really, really easy to find. It's not a formula on this one. To form this, we took 64,750 and we added or subtracted the margin of error. That's all we did. We added or subtracted something. So the margin of error is nothing more than taking one of these numbers and taking away the middle, 64,750. And that's going to give me what, 2,250? Seems legit. And then I need the plus or the minus symbol because I added it to this number and I took it away to form that confidence interval. All right, moving forward to 5. Nope. 6. 6 is a little bit different because 6 is talking about a 99.7% confidence interval. The National Center for Education Statistics surveyed 4,400 college graduates about the length of time required to earn a bachelor's degree. The average was 5.15 years with a standard deviation of 1.68 years. Based on the above information, construct a 99.7% confidence interval for the mean time required to earn a bachelor's degree by all college students. All right, so For this particular problem, because it's a 99.7, and I'm thinking about this rule right here, by the way, which hasn't clicked for a lot of y'all. 1, 2, 3. 99.7 is 3 sigmas away, and that's going to be over the square root of n. And remember, a confidence interval, which I'm just going to abbreviate as CI, is going to be the mean minus the margin of error through whatever the mean plus the margin of error is. That's how I actually construct the dang thing. All right, so we got 3 sigma, 1.68. That's sitting over the square root of n, 4,400. Hopefully it's pretty small here. 3 times 1.68, sitting pretty over the square root of 4,400 is going to be tiny. 0.076. That's how I'm going to round it. Now I can actually construct my confidence interval. All right, so I've got 5.15. I have to take away 0.076. Let's not risk me being wrong right now. I got up at 4 a.m. this morning. The left boundary is 5.074, so me and math in the head today just not mixing. The right-hand side is where you take that average, 5.15, and you add. .226. So what we could say is we are 99.7% confident that the true mean from that sample lies between those two numbers. All right, moving forward. Let's just do this one. The table below represents a sample of 40 ACT scores from Milbrath County. Assume that ACT scores are normally distributed. I remember when I made this question, I had just a really horrible group of juniors, so there's a reason the numbers are kind of low. It was just a bad year. Let's see, we're going to go stat edit. None of you are going to play along. You're just going to pretend you know what you're doing, right? You should always play along. You should. It's hard enough when you're not pushing buttons. We've got a frequency distribution table here, or chart. Some bad scores in here. And again, I remember I made this question. It's based off the seniors that graduated in 2025. It's not the current group of seniors. It's the one that preceded them. I might have to make up a question about the current group of juniors, though, just so I can remember you for all time. And then, of course, you got your frequency table there. By the way, this data is not normally distributed. If you're looking at it, you're probably thinking it's skewed right. If you have no idea what I mean by that, you need to look up what it means to be skewed. But this data is definitely not normally distributed. Since this is a sample, we do things a little bit different. This is a sample, stat, calc, 1var stats. Notice I've got a frequency list in there, L2, that's second 2 to put that there. Enter. And X bar is always the mean, whether it's a sample or a population. But since it's a sample, this is my standard deviation. So X bar is 18.4, and we're going to say that this is 5.697. And I will not remember that. I got 18.4, and S of X being 5.697. All right, now we want to construct a 95% confidence interval. To construct a confidence interval, you got to find the margin of error. It's 95%, so the margin of error is 2 sigmas sitting over the square root of n. So sigma ended up being, in this case, S of X, 5.697. Says there's 40 ACT scores sitting pretty over the square root of 40. we got twice 5.697, and that's sitting pretty over the root 40. And it's about 1.802. Now remember, you're going to do your confidence interval. This number on the left is going to be 18.4 minus. The number on the right is going to be 18.4 plus. So we got 18.4 minus that thing, 16.598 through, because it's about range. That's why we use the through notation there. And then we got 18.4. I don't know why I'm doing this in a calculator. Apparently I am that tired. I feel kind of insulted now. 20.202. All right, part 3. Weakley County believes that its students are performing significantly below or significantly worse than the national average. Compare the national average of 19.4, because this is from 2023, and that's what it was in 2023, to the interval from part 2 to see if Weakley County, and it should say that, this is from 2023. From part 2 to see if Weakley County Schools is justified in their claim. If a score is significantly worse or better, it will lie outside and to the left of the interval. No, Weakley County is not justified in their claim because this lied within the interval. So their score of 18.4, sorry, the national score of 19.4 lies within Weakley County Schools' 95% confidence interval. Now, had that 19.4 been something like 20.9, Weakley County Schools could have made that claim. What this means right here, and I know this is kind of funny, especially since that doesn't look like a 16, but it is. But this means that Weakley County school system is 95% confident their true mean lies, put this up here, between 16.598 and 20.202. So it turns out that Weakley County students, while slightly below average, are not significantly below average. Big difference in those things. And that's your homework off of 11.5. You're welcome.